Hello, Timothy. Here is Mr. Samples, your teacher of maths. Okay, we continue our program of mathematics. We are in grade 8. So we continue with our chapter that we started last time about polynomials. And today we continue the introduction with the point 4. Here you see how we start with point 4 is like terms, and what you know as you learn with algebraic expressions that like terms are the ones which have the same variables. You have the same variables and you have the same exponent. Okay, so I have given some examples here. This is number 1. If they want you to determine like terms, okay? If they want you to determine like terms with number 1, we can circle like terms. So you see elements which have the same exponents. I have exponent 5 here, variable x, and here 5 variable x. So I can say that they are like terms. So I can say 4, I can circle this or I can underline. I can say 4x on the 5th power and x on the 5th power. They are like terms. Is it clear? They are like terms. So apart from this, can we see other? I see here 3x squared times y, and here 3x y squared. They are different. But 3x squared, y here and here y squared. So you cannot say they are like terms. You cannot add them. So like terms in this polynomial we have only 2 terms that we can say that they are like terms. So we say 4 and x on the 5th power and x on the 5th power are like terms. Are like terms. We go with number 2. I see x and y. If you see here, there is no x and y. You cannot add this and this because here we have x squared. So they don't have the same exponents. They are not like terms. X squared and x squared, you see? So here they are like terms. So I can say 4x squared and 8x squared, they are like terms. Apart from this, you have x and x. They are also like terms, okay? So you can underline them, x and x. So I can take the second. We have 6x and 5x. Also, they are like terms. Are like terms. So to identify like terms, they will help you to add or to subtract. Because if terms are not, you don't have like terms, you cannot add them, you cannot subtract them. You understand? That's why you need to comprehend. When you have polynomials, you have to identify which variables are like terms or which terms they really are about the same. Now, this, apart from identifying like terms, you have to know how you can reduce in the simplest form a variable, okay? Because if you have different like terms, you can also simplify them. So here I have an example, reduce in the simplest form the following expressions. I'm going to work number 1, and number 2 you will work on. You understand? Okay, now here if they want you to simplify, it means you have to collect together like terms. That's why I wanted you to understand what is like term or what are like terms. Now if we see, we say we need to have the same variables and the same exponent. If you can see there, if I have on the 4th power, I have x on the 4th power. Do you have x on the 4th power? Yeah, very good. So we can collect them. If we collect them, we will have for number 1 we have 5x on the fourth power, you can underline so that you cannot take twice. And with this, minus 2x on the fourth power, plus, we go to the next 6y cubed. Do we have y cubed? Yes, very good. This and this. So we will have 6y cubed minus 2y cubed. Plus, we continue. Apart from this, xy square. Here, very good. We collect this and this, we collect them. So we will have 5xy square and 5xy square and plus 3xy square. Plus, we continue. So when you collect, you underline. And x square y. We don't have other x square, okay? So it remains only this and here. Two elements that we didn't collect. So we will have plus x plus x plus x plus the element that we didn't collect minus 5x squared y. Thank you. So we can use the property. So they have the same. 5 minus 2, we have 3. X on the fourth power. Here, 6 minus 2, we have 4. Y cubed. And over there, 5 plus 3, we have 8. 8x y squared plus x minus 5x squared y. It's very easy. Okay? So to collect like terms, you have to identify the same variables. Is it clear? Now we go to the last point, how you can find the numerical values of polynomials. So to find the numerical values of polynomials, you just need to substitute the value that they give you, you put in the variable, okay? You have an example. This is a polynomial, and they want you to substitute the value of x, you put 1, okay? So it's very easy. What you need to do, you write the polynomial when you substitute y, you put minus 1, x you substitute with 1, we will have minus 1, and here we have on the fourth power minus 1, and over there 3 plus 2 minus 1 square plus 1. So you now with this you can use all the properties that you learned with integers, okay? So if we continue, we will have 2. The exponent is an even number, so it will be positive. And here, it is odd number, it will be negative, minus 1, plus 2. The exponent is even number, it will be positive, so we will have plus 1 and plus 1. So we go quickly. If you multiply 2, and over there you have plus 1, here you have plus 2, over there plus 1. So if we calculate, we have 3 and 3. So the solution, the answer is 6. Very good. So you see, you will have, we are at the end of our today's lesson, and you will have some exercises through our platform that you will work and send us your answers, okay? So don't forget, in this period of this pandemic of coronavirus, respect all the measures set by WHO or all our authorities. If you want to sneeze or cough, use a health board, respect the social distancing, wear your mask. my friend Timothy. May God bless you. Let us meet for the next lesson. Thank you.